Hi everybody, so this would be a quick demo on public key infrastructure. So in this quick demo I'll be basically talking about the limitation of two-key asymmetric crypto system. So basically the insecurity of HTTP protocol. Then I'll talk about how the public key infrastructure or PKI solve this limitation by using certificate authority. Then I'll talk about how the certificate authorities process and issue digital certificates. And finally in the demo I'll show you how to create a certificate authority, how to create a certificate signing request, and how to sign that request. So basically I'll first show you the unsecured version of a website, then I'll show you how to make that website secured. So we all know that HTTP is not secured, and this is because of the man-in-the-middle attack. So if we consider this typical situation of a HTTP protocol, if we see that if you would like to see if the user is communicating with the server, so the communication would be something like that. The user will open a connection and request data from the server, and then server respond by processing the request and close the connection. Now all the communication and data are encrypted here. So what's the problem? The problem is the user does not know user does not have any way to verify whether this public key is indeed the public key of this server. So attackers take advantages of this limitation and make the man-in-the-middle attack. For example, if the user communicating with the server using some Wi-Fi hotspot which is controlled by an attacker, then attacker basically can mediate all the communication between user and the server. So basically this the public key of this server is public, so attacker can get it and attacker can send his public key to the user. So basically whatever the data is coming from the user, the attacker can decrypt in, and whatever the communication or the data is coming from the server, attacker also can decrypt it. So basically the attacker pretend as a user to the server and a server to the user. So in this way the attackers can get all the data between the user and the server. So, and as I said, the root cause of this limitation is that, or this man-in-the-middle attack is that user has no way to verify whether the public key belongs to the website that they intend to access to. So what is the solution of this limitation? So the solution is to use digital certificates. This digital certificate will allow the user to verify whether the public key is the right public key or not. Now how to issue this digital certificate, or who is responsible for issuing these certificates? So the certificate authorities are responsible for issuing this certificate. So the certificate authority is an entity, and the technology the certificate authority is used is called public infrastructure or PKI. So there are many certificate authorities. So this is the top 10 certificate issuers in 2020 according to the TechRadar news. And so there are lots of these certificate authorities. You can choose whatever you would like to choose. Now how this certification process works. So basically if you have a web server, then you have to create and then it will have two keys, like the private key and the public key. Now once you have this key, you can send a certificate signing request with this public key to a certificate authority. Now as I said before, you can choose whatever certificate authority you would like to use. So once the certificate authority get this CSR request, it can verify this request and can sign it using its private key. So this certificate authority will also have its own private and public key. So it uses its private key to sign this certificate, sign the request that coming from this web server. Now the user machine, for example, if the browser of the user machine would like to access this website, it can get this certificate, and it can also get the public key of this certificate authority if it's very well known. Now once it extract this certificate, it can basically verify whether the public key is indeed for this website. So in this way, the user machine can verify whether the public key is indeed for this particular web server. Okay, so demo time. So in this demo, I am using the same version of virtual machine that you have used in your buffer overflow assignment, which is basically the seed Ubuntu 16.04. Now, for this demo, all the instructions are available in the seed security lab website. So this is the public key infrastructure or PKI lab. So you can find this instruction in this link. So I provided that link in the slides, so you can find this link and some other essential link in the very end of the slide that I presented. Okay, so now in order to demonstrate this public infrastructure thing, I first set up a insecure website, then I make the website secured. Okay, so in order to set up a website, we need the source code of the website, and in order to access that website through browser, we need a domain name. So this domain name, uses of the domain name is needed for later phases of our making the certificate for that domain. So I'll show that thing. So in order to get the source codes, so in this seed virtual machine, there are already some source code inside the var www. Then, so in this directory, you will see these are all the source code for some websites. So for this particular demo, I'll using this SQL injection source code. So you don't need to do anything in this folder. We're just using the source code of this project. Okay, so the next thing is we need to map a domain name to the localhost IP address, because we are hosting this website in this local machine. So we need to map this domain name. So in order to map this domain name, we need to go to /etc/host file. And you see there are already many of this domain name has been mapped to the local host address. So in our case, our domain is this www.seedpkilab2020.com, and we mapped it to this 127.0.0.1 localhost IP address. Okay, so once you have these two things, like this source code of this project, and you mapped the domain to the localhost IP address, you need to input this information in the Apache web server, because we are using the Apache web server to run this project. So in order to do that, you have to go to the etc, then Apache, then sites available, then 000 default. So you need an entry like this, starting from virtual host tag and ending with the virtual host tag. So basically an entry something like this. So inside that entry, we need to just add these two information. The server name would be the domain name that we have selected, and the document root, which is basically this the directory where the source code of that project that we are going to use are located. So once you have once you have make this configuration change, you can just go ahead and restart the web server. So sudo system control restart Apache service. So that will restart the web server. Okay, so once you restarted the web server, you just need to open your browser, and you just need to type the domain name that you have just created. So it's, in our case, it's www.seedpkilab2020.com. So in this case, so we are getting the page of that particular SQL injection web page. So if you click on this icon here, you can see this connection is not secure. So basically this is the HTTP connection, which is supposed to have the man in the middle attack. Now we would like to make this website secured. So in order to make this website secured, we need a certificate for this particular domain. So in order to get the certificate, we need to have a certificate authority. Now since we are not hosting this website in internet, we are not going to use a real certificate authority like VeriSign or Google's CA, something like the real certificate authority. So what we will do, we will create a certificate authority by ourselves and use that particular certificate authority to get a digital certificate from that authority. So I'll show you how to create that certificate authority, then how to create the certificate signing request, and how to get the digital certificate. Okay, so in order to create the certificate authority, you need to get the configuration file for OpenSSL. So how you can get the OpenSSL configuration file? Basically your system has already that, so you can just copy it from user leave SSL, then openssl.cnf. so this is the configuration file for OpenSSL. If you just need to copy it in some directory in your home directory. So this is the home directory. So I have already, so as you saw, I have already copied this in this PKI directory. So if I go to this PKI, so this is the configuration file. Now if I open this configuration file, you can see some folder structure that we have to maintain. So it's says demo CA in the current directory, then some other directory inside demo. So this is basically the setup here. So I have already created this directories and files. So your instruction, this public key infrastructure lab, you have all the instructions, so you can just follow that to create this particular folder structure. So once you have this folder structure and this OpenSSL configuration file, you just need to issue a command to create the public key and private key for the certificate authority. So basically you need to issue this command. So once you issue that command, it will ask for you a password. So give a password that you can remember. And in addition to that password, it will ask for some other information like the country code. So in this case it's US, state Virginia, locality name, let's say Luxembourg, organization, let's say Virginia Tech, unit, let's say CS, common name, I'm just going to put my name here, email address a@b.com. Okay, so once you provide all the information, it will create these two files. So this is the key, which have a public key and private key, and this is the certificate for the. So this command basically created a certificate authority, self-signed certificate authority. So this is the certificate for that certificate authority, and this is the key pair for that certificate authority. So once you created this certificate authority, you need to create the key pair for your website that you are going to get a certificate for. So for that, in order to do that, you need to issue this command. So this will basically create a key pair. So if we just go ahead and paste it here, you also need to give a password here and retype it again. So it will create this server.key file, which is basically, we can use it for, we can treat this key as the private and public key pairs for our domain name. Now the next step is we need to create a certificate signing request. So in order to create that request, we need to issue this command. So it's just taking the input as this server key as input and the server.csr, which is basically the certificate signing request, as output, and it also asking for some other information. So this is the password that you used for creating this server.key file. So type that password, and now you have to give some other metadata like the data that you have given for creating the certificate authority. So USB Luxembourg, I'm just giving the same information, that's fine. Virginia Tech. And in order to make some difference, I just changing the unit name from CS to EEE. And the common name, for this common name you need to use your domain name. So basically this address www.pkilab2020.com. So you have to just copy and paste it here. Email address, I'm just giving b@c.com, and challenge password, this password adoption I don't need to give. Okay, so once you complete all the steps, you will see the server.csr, which is a request. Now we have to pass this request to the certificate authority. In order to do that, you just can issue this command. So this will basically give this CSR file to the certificate authority for signing. So you just need to give the password that you used for creating the certificate for the certificate authority. So that password, now you will see from the request the certificate authority is seeing this information and they will verify this information. So once they verified all this information, they can either sign the certificate or reject it. So if you would like to sign it, press Y. Then if you would like to commit it, press Y. Okay, so now the certificate for our website, which is www.pkilab2020.com, has been created, and this is the certificate for that particular domain. Now we have the certificate for the for our website, and we also have the certificate authority. Now we need to do some additional steps to make some configuration change in order to support the HTTPS and the TLS. So we don't need to change many internal things, but we just need to change some configurations. So basically the main configuration we need to change is in the Apache web servers configuration file, which is etc apache 2 sites available default -ssl.com. so we need to open this file and edit it. So basically you need to add this information. So this information is basically has some of the information that you have already used in some other configuration files, but the main thing is here is you have to include the certificate and the key thing here. So in this case, our certificate is server.crt, which is this one, and it's located in PKI in my home directory, which is seed, then PKI, then here. And similarly the key here is this key. So you have to add this entry in this configuration file, and basically I pre-filled it, so I just going to remove the pound sign here. Okay, so once you make these modifications in this configuration file, you need to save it. Okay, so after saving it, you just need to issue some additional commands because you made some configuration change in the Apache web servers internal configuration. So you just need to issue this set of commands in order to reflect that changes. So just copy and paste these commands and issue here. Copy the second command, paste here. Copy the third command, paste here, copy the fourth command, which is basically restarting the web server. Okay, so now you have to give the password that you used for creating your creating the key for your web server. So type that password. Okay, now the web server has restarted. Okay, once the web server has been restarted, if you go ahead with the Firefox browser and put our domain name, so this is our domain name with HTTPS. If you hit enter, so you'll see your connection is not secured. So why is that? So this is because this Firefox browser has the information of the real world certificate authorities, like the VeriSign, the Google CA, the GoDaddy, this kind of real certificate authorities. This browser does not know about the certificate authority that we have created. So we have to manually import that certificate authority information in this browser in order to recognize that certificate authority. So in order to do that, you need to go to this edit, preferences, and then privacy and security. If you scroll down, you will see this view certificate thing, and inside that you will see the practical certificates, like the certificate authority that this Firefox browser knows about. So these are all the real world certificate authorities. For example, this is the GoDaddy certificate authority, or you can also see the VeriSign certificate authority. So what we need to do, we need to import our certificate authority here. So in order to do that, you just go ahead and import our certificate authority. So our certificate authority information is stored in this PKI folder, which is this ca.crt. So once you import that, you can view the information in that certificate authority, and you need to trust that certificate authority. So once you trust that, you just go ahead and click OK. So now if you reload this page, it will give you the lock icon, which is basically meaning that now this connection is secured, and the protocol is HTTPS. So if you click on that lock icon, you will see secure connection. You can see more information from here. So this is how you can set up a website that support the HTTPS and also the TLS. So the TLS part is not visible here because that is internal of HTTPS, because HTTPS work with TLS. So hope this demo helped you to understand more about the certificate authority, how you can create the digital certificate, how the certificate issuing process looks like, all these things. And finally, so I have some reference information for you, like the link and some of the commands that I used here. So you can just use the commands from this slide to complete some of the task. Now from this instruction, I basically covered many things, but you can just go ahead and do all the tasks step by step. So if you complete all the tasks step by step, you will have a complete understanding of how the public key infrastructure thing is helpful, and how it can solve the limitation of the two key asymmetric crypto systems limitation. Basically, how it can solve the man in the middle attack. So that's for this demo. Hope you have learned something.